Okay, hi everyone. My name is Iosif Spartalis, and I am an research associate at the Urban Water Management and Hydroinformatic Group. And I also want to welcome you from my side to the Nessie as a Service API demo. Let's say a few words about the Nessie as a Service, for short NaaS. Let's say a few words about data model. Our team have tried to create a relatively simple model, but also versatile at the same time. So our product could cover multiple use cases. As you can see on top of the data model hierarchy, there is the project entity, which has the property name as a global unique identifier inside the NaaS platform. In addition, the project entity can own multiple sensor entities, and each sensor entity can own multiple time series data. Please note that each sensor instance has a property with a name code, which is unique within a project instance. And through this unique code, time series data can be connected to the corresponding sensor. Also, the NaaS data model has a simulation scenario entity in which the user can store results of a simulation scenario or a model or any kind of process data. I will talk about this in more detail later on. Returning to the project entity, our team created two roles, one of a project administrator or project admin for short, and one role of project member. Project admin has elevated privileges over a project instance. Among other actions, project admin can create sensors, store sensor data, create project members, authorize project members to view specific sensor data. Please note that there must be at least one user with a role administrator role in every project instance. On the other hand, the project member role has limited rights. A project member can only view authorized by the project admin sensor data and can create only simulation scenario instances. Now, in today's demo, we assume that our main user has project administrator rights over a given project instance. So after saying a couple of things about the API authentication, I will proceed with how to set up a project, which means, in other words, how to create a sensor instance, how to store sensor data, and finally, how to create users with project member roles and assign to them sensor instances, although this step is optional. Also, we are going to see how we can retrieve sensor data, and finally, how to create a simulation scenario instance. Before we proceed to the main API usage, let's talk about how the authentication works. The authentication of NaaS API uses a token-based authentication, which means each HTTP request must contain in its header section a unique token that the user has acquired previously. So in order to obtain this token, we must send an HTTP post request at this URL that you can see here. Now, because at the moment we don't have a permanent domain name for our platform, I enclosed in curly brackets the section that normally will be the main internet address of Nessie. So ignoring this part of the URL, we must turn our attention to the term service, which is the main subdomain for the NaaS API. In other words, all NaaS API endpoints starts with a service keyword. So for the API authentication URL, we must add the API-auth keyword behind the service keyword. Now, the HTTP request body must be in a JSON format and must contain the terms username and the API accompanied by their values. I must point out that the API key is a long string, much bigger than an ordinary password. and every API user must obtain this key from our team. Needless to say, this API key must be kept secret. Now, let's see how we can get this token with a hands-on example using the Postman application. So I will stop the presentation and go to the Postman application. I don't know if you are familiar with Postman. Anyway, long story short, Postman is a very handy application for creating HTTP requests through a graphical interface. So for this demo, I've created a project instance named iWidget and a user with project admin rights. The user has the username iWidget user iWidget underscore user 1. So as I said before, I'm in the Postman environment. Here I select the request method that I'm going to use, and here I put the URL of the endpoint. As you can see, it's service/API auth. Now I go to the body. I select to be a JSON here, and I'm going to type the username, which it will be iWidget underscore user 1, and I also have to include the API key, which is so let me copy paste it. So press send, and now the response body includes the user that made the request. This string is the token that I have to copy. Now the expiring in value returns how many seconds are remaining before the token will be expired. In other words, the acquired token has a limited lifespan, and if this amount of time has passed without the user making any HTTP request to the API, then a new token must be acquired with the same method that I have just described. On the other hand, when the user makes an authenticated HTTP request to the API, then the lifespan of the existing token is renewed, so the user can use the NaaS API continuously. Now, let's go back to the presentation. Let's move on and see how to set up a project. First, we need to create some sensors. To do that, we must send a post request at this endpoint URL for each new sensor that we want to create. So in this URL, we have the keyword service, followed by the keyword project sensor and the project name. As I mentioned in the authentication section, I have already created a project with the name iWidget. So the URL for creating a sensor in our case will be this one. This one. The request body must be in JSON format and must contain these keys. The values of those keys are strings. The code must be a unique string within a project, and it is used as an identifier for each sensor. Code string must contain only alphanumerical characters, underscores, and hyphens. So that means no spaces and no special characters. Name is a human-friendly name for the sensor. Property contains the property that the sensor is monitoring, like water flow, energy consumption, etc. Unit contains the unit symbol of the property that is monitored, liters per hour, kilowatts, and so on. Time step is the time interval that the sensor collects information. For representing this time interval, in a cohesive way, we adopted a fixed typology method. As you can see, we use the letter D for representing days, the letter H for hours, and so on. So let's say, for example, that a sensor makes a measurement every 2 hours, then the timestamp value will be 2 followed by 8. So if the time interval was 5 minutes, then the timestamp value will be 5 followed by T, 5T, and so on. Let's create, I will go back to the Postman application and try to create a sensor. So as I said before, the request method must be post. Here is the URL. I will replace this one with the project name, which is in our case iWidget. Now, as I said before, I have to include in the header section a key, an authorization key, and the value must be token plus the string that I have just acquired. Let me copy again. Copy this string, and I will paste it here. Okay, so now this is in the headers section. I will go to the body section. As I said, it must be in JSON. And okay, let's create a sensor. We must include code. Let's say will be dummy sensor 1. The name again, dummy sensor 1. Okay, the name is versatile, can include special characters and spaces and other things. The property that the sensor is monitoring. Let's say water flow. The unit. The liters per hour. Sorry, hour. The time step. Let's say that the sensor takes measurements every 5 minutes, so it will be 5T. Okay, and let's try to send it to the API. Oh, sorry. Also, I have forgot to include remark. I'll leave it empty. Okay, the sensor is, we have returned HTTP code 201, which means that the sensor was created successfully. Okay, that's it. Let's go back to the presentation. Okay. So now let's try to store some sensor data. The URL endpoint is the one that you can see here, /service /data/sensor and /sensor URN. Now let's say a few things about what the sensor URN is. URN stands for Uniform Resource Name and acts as a global identifier through the whole NaaS platform. The way that the sensor URN is structured is quite simple, and it is consistent of certain keywords separated by colons. The first keyword of a sensor URN, it is the URN keyword, which is followed by the NaaS keyword, then followed by the project name of which the sensor belongs to, followed by the sensor keyword, and finally followed by the sensor code. For our demo, let's say that we want to create data for the sensor that we have just created in the previous step. Then the URL will be this one. The request body must be in JSON containing these value pairs. Timestamps, which is a list of ISO 8601 timestamps with time zone information. The key values, which is a list of values that corresponds to the sensor measurements. And flags, which is an optional keyword, and it is a list of strings that may describe any additional information that accompanies each measurement. Please have in mind that all of these lists must have the same length. So let's go to the Postman application again. So I will type in the URL, is service slash data slash sensor slash the sensor URL, which will be, let me copy it. With this one, URL, NaaS, column, iWidget, sensor, dummy sensor one, slash. So I will also include the authentication method to the request headers. Application, again, have to type the token keyword. Copy again the token. Let's go to the body. Select row, JSON. I forgot I have to select that the request method must be post. And let's create some data. Okay, first timestamps, which is a list of ISO dates. Let's say it's 1 to 1 to 4. Okay. And the time zone. Okay, I will copy paste the other ones to save time. Let's say that we want to create 3 values. Okay. Now, let's fill in the values. Let's say maybe 10. And hopefully we can fill the flags keyword. It may contain any information that accompanies the previous measurements. Let's say the first measurement is a valid measurement. The next one is invalid. The last one valid. So okay, here's the JSON body. We'll press send. sorry. Okay, there was a problem. Let's go to the header section. Maybe this. Okay. Oh. That was sensor one. Sensor one. Okay, there is a problem here. Okay, I will continue. I don't know what happened, but you get the point. So I will move on to the next slide. Let's say now that we want to create some users with project member roles and assign to them some sensors. There is a dedicated API endpoint that creates multiple users with only one request. So we must send a post HTTP request with a JSON body that contains a list of JSON objects. This JSON objects corresponds to each new user that we want to create. The mandatory keys per user JSON object are the username, password, the email, and sensors. Sensors is a list with the sensor codes that the particular user can have access to their time series data. So let's go to the Postman application again and make some users. Here I will copy paste the URL. Service project users paths /iWidget. I will copy paste the token. Okay. Now going back to the body. I will copy paste the JSON. Let's say that we want to create two users. The first one, we will have access to the sensor with the sensor codes. This sensor code. The second user will have access to 3 sensors. Also to the sensor that we have just created. Okay. So I will press send, and we have this response. So that says that the user has been created successfully. Now, let's go back to the presentations, and now let's try to retrieve some time series data from a particular sensor. The URL has the same structure with the one of storing sensor time series data. The only difference here is that the HTTP request method, which is it is a get method instead of a post. So let's go to the Postman again. So let's say service data sensor / I will type in the sensor URL colon NaaS, the project name, which is iWidget, colon sensor colon and the sensor code. Let's say, okay. Let's say that we want to retrieve data from the sensor underscore 40. I also have to include the, almost forgot that, the authorization token in the header section. Authorization token. Okay, again, the token. Okay. I will press send. And here in the response body, we have the data, time series data from the sensor with sensor 40, let's say. Okay, all this data, which is a JSON body with the timestamp followed by the actual measurement. Now, let's go back. Okay, now, finally, let's say that we want to create a simulation scenario. With the term simulation scenario, we want to cover the case where the user can run a model or a function which takes certain input, certain input parameters, and then an output is produced. This output could be a future prediction, a simulated scenario, or anything else. So in order to create a simulation scenario, we must send a post request to this URL with body in JSON format containing this information. The name of the scenario, which must be consistent only with alphanumerical characters, underscores, and hyphens. The input parameters, which is a JSON object with a non-defined structure. The user has the flexibility to include whatever she wants. The same stands for the results. Again, the content of the JSON object is defined by the user. So let's try to create a simulation scenario. This time I won't be using Postman. I have prepared a Jupyter notebook and wrote some simple code in Python. So let's create a simple example by retrieving data from a sensor, calculate the sum of all the received values, and then store the result to a simulation scenario instance. So first, we are going to retrieve data from the sensor 40. Okay, I'm importing here the requests package, which is a library in Python for creating requests, HTTP requests. Here, I assign the temporary NaaS API domain to this variable, NaaS domain variable. As usual, we have to get the authentication token first. So I create a dictionary with the credentials of the iWidget user one with the API key, and I make a request, a post request to the authentication URL with these parameters. Okay, let's see the response body. Okay, the same. Here is the token, and here this the remaining lifespan in seconds. Now let's store the token string into the variable token, so we can create it so we can use it later on. Now let's do the actual request and get the data from the NaaS API. Here is the sensor URL. I store in headers variable a dictionary with the token containing the token. And here I structure the URL for the certain sensor. So, and in this line, I run I execute the request which is a GET request. Okay, so here are the returning data, which is in JSON format. So let's do something useful with this data. I will use Pandas library, and I will put this data into Pandas series object. Okay, and now I have the ability to calculate the sum of these values. So now let's move on and create a simulation scenario instance. Okay, by constructing the request body. So here I name my scenario total water flow. The input parameters. Okay, I can have the flexibility to include whatever I want. So I choose to include the water flow and all the values that I have used. And the result will be the sum of all these values that I have just retrieved. So let's see the data. Sorry. So the data, the JSON body is this one. And now I will make a post request to this URL, service/sim/scenario. I will include the headers for the authentication and the data as JSON. So I will make that request. Sorry. Oh, okay, let me rename it. Rename it to because this scenario name is already exists. It already exists, and there is a conflict. So let's try it again. Okay, now the simulation scenario is created in the NaaS platform. As you can see, the response code is 001, which means that the simulation scenario instance has been created successfully. That's all. Let's go to the presentation. So finally, I want to point out that all the functionalities of the NaaS API are described in the documentation stored in a Bitbucket repository. And that's all. Thank you for your time.